Hello everyone. Today see about the class engineering chemistry in the topic nanocluster, a new pathway to nanotechnology applications. Next, see about the topic nanocluster. Nanocluster are atomically precious crystalline material most often existing on the 0 to 2 nanometer scale. They are often considered kindly stable intermediate that form during the synthesis of comparatively large materials such as semiconductor and metallic nanocrystals. Size and number of atoms in metal nanocrystal. According to the Japanese mathematical physicist Raiko Kuba, the spacing of energy level can be predicates by lam sorry delta equal to EF by n, where EF is Fermi energy and n is the number of atoms. For quantum confinement, delta can be estimated to be equal to the thermal energy, where K is Boltzmann constant and T is temperature. Next, stability. Not all the clusters are stable. The stability of nanocluster depend on the number of atoms in the nanocluster, valence electron count and enclosure subcode in the 1990 year, and his co-work used supersonic exponential of an atomic cluster source in a vacuum in the presence of a intergas and produced atomic cluster beam. The number of atoms or size of the core, the magic cluster, correspond to the closing of atomic shells. Certain theolate clusters such as AU25, 18, AU38, 24, AU102, SR44, and AU144, SR60 also show magic number stability. Electrons correspond to the shell cluster of atomic orbitals as 1s2, 1p6, 1d10, 2s2, 1f14, 2p6, 1g18, 2d10, 3s2, 1h22. Next, synthesis and stabilization. So, solid state medium. Molecular beam can be used to create nanocluster beam of virtual any element. They can be synthesized in high vacuum by with a molecular beam technique combined with a mass spectrometer for mass selection, separation and analysis. And finally, dedicate with dedicators cluster source. Seed supersonic nodes are mostly used to create clusters of low boiling point metal. In the source method, metal is vaporized in hot oven. The metal vapor is mixed with intercarrier gas. The vapor mixture is ejected into a vacuum chamber via a small hole, producing a supersonic molecular beam. The expansion into vacuum produced cooling the vapor. The cooling metal vapor become superstratus condensing in cluster form. Next, mass analyzer. Wine filter. Mass separation is done with crossed homogeneous electronic and magnetic field perpendicular to ionized cluster beam. The net force on a charge cluster with mass m, charge q, and velocity v vanishes if E is equal to bv by c. The cluster ions are accelerated by a voltage v2 and energy qv passing through the filter cluster with m by q equal to 2 volt by ec divided by b, or undeflected The undeflected cluster ion are selected with appropriately positioned collimator magnetic properties. Most atoms in a nanocluster are surface atoms. Thus, is expected that the magnetic moment of an atom in a cluster will be larger than that one in a bulk material. Lower coordinate, lower dimensionality, and increasing interatomic distance in a metal cluster contribute to enhancement of the magnetic moment in nanocluster. Metal nanocluster also changed in magnetic properties. For example, vanadium and ruthenium are paramagnetic in bulk but become ferromagnetic in nanocluster. Also, magnesium is antiferromagnetic in bulk but ferromagnetic in nanocluster. A small nanocluster is a nanomagnet which can be made nanomagnet simple by changing its structure, so they can from the basic nanomagnetic switch. This is for a nanotech size and structure. Next, reactivity properties. Large surface to volume radius and low coordination of a surface atom are primary reason for the unique reactivity of nanoclusters. Thus, nanoclusters are widely used catalyzed. Next, optical properties. The optical properties of material are determined by their electronic structure and band gap. The energy gap between the highest occupied molecular orbit and last unoccupied molecular orbit varies with the size and composition of an nanocluster. Thus, the optical properties of a nanocluster change. Furthermore, the gap can be modified by the coating the nanocluster with different lignets or surfaces, coating a layer of the nanoclusters. Next, see about the topic nanotechnology. Nanotechnology is the main population of matter on a near atomic scale to produce new structure, material, and device. The technology promises scientific advancement in many sectors such as medicine, consumer products, energy, materials, and manufacturing. Nanotechnology refer to energy engineered structure, device, and system. Nanomaterial have a length scale between 1 and 100 nanometers. This is a picture for a nanotechnology. Next, large to small. Several phenomena become pronounced as the size of the system decrease. This includes statistical mechanical effects as well as quantum mechanics effects. For example, the quantum size effect, where the electronic properties of solid are alternated with a great reduction in particle size. The effect does not come into play by going from macro to micro dimension. However, quantum effect can be become significant where the nanometer size range in reached typical at distance of 100 nanometer or less than the so-called quantum realm. Next, synthesis to simple complex. Synthesis chemistry has reached the point where it's possible to prepare small molecule to almost any structure. This method are used today to manufacture a wide variety of useful chemicals such as pharmaceutical or commercial polymers. This ability raised the questions of extending this kind of control to the next large level, seeking methods to assemble this single molecule into supermolecular assembly. consisting of many molecules arranged in well-defined manner. Molecular nanotechnology. Molecular nanotechnology, sometimes called molecular manufacturing, describing engineered nanosystem operating on the molecular scale. Molecular nanotechnology is especially associated with the molecular assembly, a machine that can produce a desired structure or device atom by atom using by the principle of mechanism, mechanical synthesis. Manufacturing in this context of producing nanosystem is not related to and should be clearly digested from the conventional technologies used to manufacture nanomaterials such as carbon nanotubes and nanoparticles. Thank you for listening this class.